Good morning, developers. If you are new to the channel, my name is Rob, and it is JavaScript Tuesday, the day that we focus on JavaScript, keeping our core JavaScript skills sharp. And we've been going through the updates to ECMAScript since ES6. A lot of great stuff has happened since 2015. And if you need a little background on how those are related, ECMAScript and JavaScript, I'll drop a couple links in the description. But today we are in ES11 with the all-settled method that belongs to the promise constructor. Over here on the left-hand side, you can see here we are with the promise constructor. Most of these came with ES6, so promise.all, promise.catch.race, reject, resolve, then. The other ones have all been added since, and so I'm handling them in order. Finally, I just did, and I will drop that link in the description as well. I don't want to spend a ton of time on how promises work because if you don't know, this is not going to be all that useful, although you may learn a ton about promises. If you do, and you just want to know how all settled works or what the difference is, I'm going to do a real quick promise example. There should be a time on the screen somewhere that will tell you where to hop to. But over to the code editor quick, I've got allsettled.html opened up. You can certainly use Node.js if you want to. In ES6, like I said, promises came out, and it was a massive improvement because the power of JavaScript is its async nature. As I will show you, and you're probably already aware, maybe even frustrated, but it is a nightmare to try and manage well if the program gets any size, because you can end up with literally 15 callbacks inside each other, and it's ridiculous. Promises mostly solve that. I wasn't really happy until the next year when we got async and await. But going forward, more stuff has been added, and finally, and now all settled. To show that, let's put an example together real quick. I'm going to put at the top level here, const run. I want to be able to use async and await, so I'm going to run it like this. You don't have to do this, but you'll have to use thens, and I'm going to try and avoid using then. Run is going to be our whole program. So we've got our script tag. Run is going to pop on program load. Okay, what happens inside run? Well, this style tag, I have exact same thing in the finally video. There's nothing here other than to make it look a little better. We got two input buttons, one with start1, start2 on it, and two different IDs, B1 and B2. If we come over to the browser, this is what it looks like. They do absolutely nothing, nothing yet. Back over here inside of run, I wish there was another way to simulate promise as well without using set timeout or set interval, but it's the most consistent way to get it in there. So we're going to do this. We're going to do const, we'll call start timer, and this is going to be a function. We're going to expect, let's call it button dom L. And button dom L is going to be either B1 or B2. So let's go ahead and get that started inside of run. I'm going to call start timer, and we'll pass the string B1, and we'll pass the string B2. Again, I'm doing everything inside run because we can't run async at the top level unless it's a module, at least at this point. We could use Webpack, but this is not important enough to do that. So start timer is going to run, button dom L is going to be B1 and B2. We will do this. We'll do const timer equals set timeout. We'll run a callback, and we will wait for 3 seconds. And we'll put in here for now console.log timer has expired. Down below, actually still inside of our start timer, so outside of our timer, it'll be right here. We'll do a document.getElementById, grab the thing with the ID of button dom L. So this is going to be B1 or B2, and add an event listener. We're going to add a click listener, and we will run this callback if that happens. All right, so on load, get the timer started. This will happen. Run the set timeout. This will not happen, though, until this much time has passed. So this will go ahead and get registered as well. Add an event listener. Run this callback if it happens. What will we do? Well, we are going to clear out our timeout because that has happened, and we will console.log timer has completed or something like that. It doesn't make any difference. The way the program works is, I'm sure you can see here, we've got this one. B1 comes in. We set up a 3-second timer that, let's put at the beginning here, button dom L, so we can see which one has expired. We'll do the same thing down here. This is going to run in 3 seconds unless this gets clicked on, in which case it will clear out the timer and then this will run instead. Yes, technically you can still do this after the timer has finished. There's no reason to remove the event listener. This is already plenty for our example. The point is we have two async things here. We have a set timeout, which is going to wait 3 seconds. So this callback will not get run until something happens. The same thing here, this click, right? This callback will not get run until this event listener happens. So if I save it, hop back over and refresh, I'm not going to click on anything. Down below here, we get B1 and B2 have both expired. If I refresh, click on the first one, this one completed, B2 expired, refresh, click on them both, you get the idea. Now, why would we need promises here? Well, what might happen is we've got something down here. Let's put a note in. This next thing happens after both button timers are complete. So I'll console.log, buttons are done. Okay? This won't run until after both of these are complete, right? Of course not. That's not how JavaScript works. Line 30 runs immediately because it can. JavaScript will never wait to run the next line, and that's exactly what's happening here. The lines that run in order, this one runs first because we call run. That means back up here, this is going to get run. Start timer, this is a function, so it gets registered. It's not going to get run yet. Pass all that. Okay, 26. Call start timer and pass it B1. So this runs, this has to wait, and the only way that this is ever going to get run is if 3 seconds passes. This gets run, and the only way this is ever going to get run is if click happens. So we're done with the function for now. The same thing happens with B2. JavaScript has to wait, and JavaScript doesn't wait. Down here on line 30, that's going to go ahead and run, and then those callback events happen back up here. Okay? Now, if we want to hold this off, we're going to have to change this to where it returns a promise. So inside here, start timer, I'm going to get rid of the bracket and we will do a new promise, open, close, resolve, and reject. So this is promises 101. I've got start timer is a function that returns a new promise. If you don't like the way this looks, you could put the bracket back in there and put return. This is just how arrow syntax work. I prefer brevity like this. This callback gets started, this function gets started. Down at the bottom here, we need to close off our function like that. So run starts here. Start timer simply returns a new promise. That function gets started here, and it closes down here. Okay, so I can scroll over a little bit if you need to see that. But the way that the program needs to work now is instead of just console.logging, we're going to pass reject, or rather we're going to call reject here, and I'll put in there just, I don't know, button DOM-L, so we have it. We probably won't use it. Down here we will resolve, and we will pass the button DOM-L as well. This means the right thing happened. Here's your data back. This means something went bad, and I'm gonna call reject. Well, since this is returning promises now, both of these are equal to a promise. And the way that I typically do this is we're going to make an array here. I'm going to do const, we'll call it promises, make an array. This will be thing 1, and this will be thing 2, and we'll close off our array. Let's call it actually, let's call it timer promises, just so it's a little less vague. So timer promises now contains 2 promises, and we can use, we'll grab timer promises, we're going to do promise constructor, so .all, and we'll hand it timer promises, and I'm going to put at the front of that await. So this is, we can't go past this line until the .all happens, which means all of these have finished, and this will work. Back over here and refresh. I'm not going to click on anything, and we get timer's expired, and we get an uncaught in B1. Well, what if I refresh and I click on both? Okay, that's good. Well, buttons are done, so everything worked out okay, right? Well, the reason that this never ran is because all never finishes, because all only runs. Back over to the docs here, click on all. The all static method takes an iterable of promises, that's what we've got. We've got an array as input and returns a single promise. That's what our await is. We're waiting for a single promise. This is our iterable of promises. All right, this return promise fulfills when all the input promises fulfill with an array of the fulfillment values. It rejects when any of the input promises reject, which is the first rejection reason. All is not meant to handle rejections. If we go back one, all settled, static method takes an iterable of promises, just like we've got here. We've got an array of 2 promises, and returns a single promise. It is exactly the same verbiage that we just read. This return promise fulfills when all the input promises settle. So let me try and line this up here. I'm going to open up all. I'm going to scroll down just a little bit here. Okay, so we've got them like this. They are pretty much identical, other than all settled is a little bit longer, so it's moving the text over. The return promises fulfills when all the input promises fulfill. Highlight that. Highlight it there. Okay, those are pretty much identical. This one says settle though, and this one says fulfill. The difference here is the concept of settled. A promise is said to be settled if it is either fulfilled or rejected. So all settled, if we come over here, and I'm gonna copy this line, I'm gonna comment it out and drop right below it the same line, but we're gonna change this to all settled. Back over to our code or back over to the browser, refresh. I'm not going to do anything. Okay? Buttons are done. It doesn't throw a catch because it's interested in are they settled. I don't care what happened. Resolve or reject, it doesn't matter. I can handle both. If I refresh, click on one, click on the other, we get the same thing. Click on one, don't click on the other. This is exactly the behavior that our program is going for at the moment here. So let's make a couple notes here quick. Dot all will run only when all promises resolve. If any reject, it will throw an error. So we'll have to catch that error. Alternatively, right below it here, all settled will run when all promises are resolved or rejected. So that is the difference. That concept of settled is really what this comes down to. It will have an array of objects with the outcome of each promise. So back over here, if we throw in here, let's do const, we'll call it results, and I will log the results. We'll console.log that. This will contain whatever was rejected or resolved, rather passed, I guess. It will contain the DOM elements. So back to the browser one more time. I'll click on start 2. I'll ignore start 1. Okay, here is what we got back on line 39. Open it up. Okay, status rejected, and the reason, that was what we passed to our reject. Status fulfilled, this is what we passed to our resolve. This is really, really useful if you ever have rejects that you're dealing with and you want to keep moving forward without having to deal with the catch. All of the data is still in here that would be in your catch. It is entirely a programming design decision. Do you want to have catches, or do you want to be able to manage everything inside all settled? Personally, I prefer all settled. It just depends on how you prefer to program. Really quick to look through the documentation. There's not a lot left here, but we pass it an iterable. It needs, generally speaking, to be an array of promises, and a promise that is already fulfilled or asynchronously fulfilled. Inside there, you saw it will come with a status, with a value, or a reason. Back over here, the status is whether it was rejected or fulfilled, and it will have either a reason or a value depending on which one of those it was. Really what this comes down to is it's typically used when you have multiple async tasks that are not dependent on one another to complete successfully, or you'd always like to know the result of each promise. Let's say you have a couple different database requests going in, they're not related, or maybe you're fetching something from an API and you're saving something to a database, maybe you're writing something to a disk, whatever it is, right? You don't need them to complete an order, so you can drop an all on it, but you don't want to have a catch. You want to just handle everything internally. All settled is what you're looking for. The promise returned by promise.all, we already saw this, but it may be appropriate if the tasks are dependent on each other and you need to stop the whole thing if any of them reject. So that's really what this is about here. If it doesn't matter which ones complete and which ones don't, this one, it does matter. They all need to finish for some reason. And if any of them fail, well, we're going to have to start over or handle it or whatever. Scrolling down, they've got an example here. We pretty much already did this. that's pretty much it. This has fantastic coverage going back a long way. Again, this was ES 2020, so it's been at least 4 years ago, depending on when you're watching this video. But that does it for this one. The next one we will look at is .any, and then we will look at with resolvers. Thanks so much for watching. I'll see you next time. Keep writing JavaScript.